வணக்கம். இது தமிழ் அண்டத்தின் திறவுகோல். இந்த உலகத்தில் வாழும் அனைவரும் தமிழர்களே. அனைத்து தமிழர்களுக்கும் என் பணிவான வணக்கம். இன்று நாம் பார்க்க இருப்பது எகிப்து மொழி ஆராய்ச்சியில் நம்மிடம் தற்போது இல்லாத உயர் தொழில்நுட்ப உச்சம் கார்டினர் G39 நாள் 14/8/2020 பதிப்பு 1.13. எனது முதல் விழியத்தை பார்க்காதவர்கள் அதை பார்த்துவிட்டு இந்த விழியத்தை பார்க்க தொடருங்கள். அதில் எகிப்து மொழி பற்றியும் கட்டுடைக்கும் சூத்திரம் பற்றியும் விரிவாக கூறியுள்ளேன். அந்த விழியத்தின் பெயர் தமிழ் மொழி 5000 வருடம் பழமையானதா, எகிப்து மொழி தமிழா? நாம் குறிப்பிடக்கும் சில புத்தகங்கள்: கார்டினர் சைன் லிஸ்ட் ஆஃப் ஹீரோகிளிபிக் சைன்ஸ் பை அலன் கார்டினர், எஜிப்சியன் ஹீரோகிளிபிக் டிக்ஷனரி பை E.A. வாலிஸ் பட்ச், மார்க் வைகஸ் 2018 edition dictionary, The Gods of the Egyptians by E.A. வாலிஸ் பட்ச், Ancient Egyptian, A Linguistic Introduction by Antonio Loprino, Sesh Kamath, Egyptian Scribe, Phonology and Phonetic Reconstruction Project. முதல் 7 பாகத்தை பார்க்காதவர்கள் அதை பார்த்து விடுங்கள். இதன் இணைப்பு விழியத்தின் கீழே கொடுக்கப்பட்டுள்ளது. இன்னும் ஒரு சிறப்பான உதாரணத்துடன் குவாண்டம் தியரியை பார்ப்போம்.
My quest begins with one of the most majestic sights in nature: migration. Every winter, barnacled geese arrive right on cue at the same Scottish river. The end of an epic 2,000-mile voyage from Svalbard, high above the Arctic Circle. Of course, many birds head south for winter, then back home for summer. But for decades, exactly how birds navigated with such accuracy was one of the greatest mysteries in biology. So the most recent discovery has caused a sensation. In the past few years, one species of bird has helped create a scientific revolution. I was one of many physicists who were shocked to discover that it navigates using one of the strangest tricks in the whole of science. It utilizes a quirk of quantum mechanics, one that bamboozled even the greatest of physicists, from Richard Feynman to Albert Einstein himself. So you might be surprised to discover the identity of this mysterious creature. Say hello to the quantum robin. This is the European robin. Every year she migrates from northern Europe to the tip of Spain and back. In this laboratory in the woods, biologist Henrik Moritzen is trying to solve the mystery of how she does it. But he's found himself in my world, the strange world of quantum mechanics. Quantum mechanics describes the very weird behavior of subatomic particles. Down in this realm of the very small, we have to abandon common sense and intuition. Instead, this is a world where objects can spread out like waves. Quantum particles can be in many places at once and send each other mysterious communications.
I set out to understand how the bird finds its way, but it just turned out that the data more and more pointed towards this as the only explanation that could bring all the different results together.
Henrik's investigating a long-standing theory that robins navigate by the Earth's magnetic field. His laboratory is an ingenious magnetic bird cage. And these plastic cones, lined with scratch-sensitive paper, provide the key measurements. Henrik's artificial magnetic field is like the Earth's, except that he can point it in any direction he likes. Inside their cones, the robins always respond to the field, leaving scratches in a single direction. The big mystery is how. The Earth's magnetic field is incredibly weak, far too weak for any living creature to detect. But Henrik has found an intriguing clue by giving the quantum robin a mask.
We have a little leather hood, similar to what you put on a falcon, you know, but just for a robin. And you have then a hole in front of one eye or a hole in front of the other eye. But what we can see is that if you cover up the right eye, you turn off the magnetic compass processing in the left part of the brain. If you cover up this eye, you turn the compass off in this part of the brain.
The robin's magnetic compass seems to be in her eyes. I can show you what's going on using my own eye. Now, we use our eyes for vision, but we also have a second light detecting mechanism. If I shine this torch into my eye, you can see that my pupil closes down. It's basically a defense mechanism to protect my eyes. My eye is responding to particles of light, or photons. The energy provided by the photons is clearly enough to activate chemical reactions. After all, that's what controls my eye muscles. Light must be causing similar chemical reactions in the robin's eyes. In fact, it's the power supply for a unique form of magnetic compass inside her cells, in the weird world of subatomic particles. A place where only quantum physics can explain what's going on. To see why, imagine the chemical reactions in the robin's eye taking place in mountains and valleys of energy. To get a reaction to start, you have to push molecules to the top of a mountain. Thanks to Henrik's experiments, we now know that light does most of the hard work. But when it reaches the very peak, the molecule becomes incredibly sensitive to the slightest touch. The key point here is that the robin's chemical compass is now balanced on an energy peak between two valleys. Going one way produces one set of chemical products, the other a different set. Now, even a tiny change in the Earth's magnetic field can tip the molecule over the top. But the way this happens defies common sense. The final piece of the puzzle depends on one of the truly mind-boggling ideas in physics. But don't worry if you find it hard to understand. Even Albert Einstein called it spooky. The idea is called quantum entanglement. It involves particles that seem to communicate faster than the speed of light. In 1935, Einstein published a famous paper arguing that it was impossible. But Einstein was wrong. In recent years, extremely delicate experiments have shown that subatomic particles really are entangled. It means they can subtly and instantaneously influence each other across space. And now it seems the same thing is going on inside the robin's eye. When a photon enters the robin's eye, it creates what's called an entangled pair of electrons. Here's how it works. Each electron has two possible states. For simplicity, I'm choosing to call them red and green. Now, here's the weird thing. Until I measure it, it's neither one nor the other, but both at the same time. Think of the electrons like spinning disks. They're simultaneously red and green. But by firing a dart, I can force the first electron to be one or the other. So far, it's just a game of chance. I don't know what I'll get until I try it. So I know my first electron is red. Suppose I now measure the second electron. You'd think I'd have a 50-50 chance of getting red or green. After all, that's what you'd expect in the normal, everyday world. But you'd be wrong. In quantum entanglement, the electrons are mysteriously linked. For example, if I get red on the first, I always get red on the second. It's not a game of chance anymore. It's as if the first electron is telling the second one what to do. That's why Einstein called it spooky. The electrons seem to know that they should both have the same color, no matter how far apart they are. The really important part is that the two electrons needn't be the same color. They can be entangled in a different way, so that if the first electron is red, the second one is always green. It seems that this mysterious connection is the ultimate secret of the quantum Robbins compass. Because the direction of the Earth's magnetic field can influence the outcome. Near the equator, they may be more likely to be red-red, but near the pole, they may be more likely to be red-green. And that's the vital factor that finally tips the balance of the Robbins chemical compass. Tiny variations in the Earth's magnetic field change the way electrons in the Robbins eye are entangled. And that's just enough to trigger her compass. Now, finally, we can see how something as weak as the Earth's magnetic field can tip that balance one way or the other. If the message changes, the chemical reaction tips a different way, changing the Robbins compass reading.
Suddenly it looks like it's a fundamentally quantum mechanical phenomenon in birds. It would be one of the first, if not the first, in biology.
Biologists better get used to the weirdness of physics. The robin is navigating by spooky quantum entanglement. To see subtle quantum effects, even in a controlled, austere environment of a physics lab, is really difficult. And yet, here's the robin doing it with ease. These experiments are real and verifiable. And yet, even though I'm seeing them with my own eyes, I still find it hard to believe. Bird navigation has brought physics and nature together as the science of quantum biology. There's a whole new world to explore. But its pioneers have found that it doesn't just affect birds. It affects every single one of us. Because the latest experiments say you're doing quantum physics right now.
இதில் ஒரு மின்னணு மற்றொன்றுடன் தொடர்பில் இருக்கிறது. ஒரு அணு என்ன செய்ய வேண்டும் என்று மற்றொன்று முடிவு செய்கிறது. அடுத்த பகுதியில் இன்னும் விரிவாக பார்ப்போம்.